Hello everyone. Today I'm going to discuss the last problem of Leetcode BiWeekly contest 154, which is shortest path in weighted tree. So what is the problem? We are given an integer n and an undirected weighted tree rooted at 1. Okay. So what are the queries given to us? The queries could be of two format. One is type 1 query, but we are given u, v and w. So what we have to do? We have to change the weight of the edge u to v to w bar. And for the second type of query, type 2 queries, we have to compute the shortest path distance from the root node to node x. Okay, I hope you get the problem statement. Now how we are going to solve this problem. For before that, let's discuss some sample cases. Let's take the second sample. So this is the tree 1 to 2 and 1 to 3. Okay, let me write it. The tree is like this: 1 to 2 and 2 to 3. So this is a tree, undirected and weighted tree. So 1 to 2 has a weight of 2 and 2 to 3 has a weight of 4. Okay, so what is the first query? In the first query, we have to find the, it's a type 2 query, so we have to find the shortest path from 1 root to 1. So root is 1 and 1 to 1 the weight is 0. Okay, so we have to find the shortest path from 1 to 1, so the answer will be 0 here. And then for the second query, uh, this is also type 2 query. We have to find the shortest path from 1 to 3. So the shortest path from 1 to 3 is of 4. Okay, now for the third query is the update query. We have to update the age of 1 to 3 to 7. Okay, we have to update the age of 1 to 3 to 7. So we are updating, changing this age to 7. Okay, now after that, in the fourth query is type 2 query. We have to find the shortest path from root to 2. Root to 2, the path has not changed, so the answer will be 2 here. Now for the last query to find the shortest path from 1 to 3, root to 3. So the path has changed now, so the answer will be 7. Shortest path is 7. Okay, now this is the answer: 0427. Now how we are going to solve this problem? So the observations, the key observation here is that the shortest path, okay, one thing is that the weights are positive. Okay, so weights are positive. If the weights are negative, you can say that we can go to let's say if it is negative 2, so we can traverse this path infinite amount of time. So that is not the case. The weights are positive, so we have to, if the shortest path will be only one path. Okay, there is only one path from root to the what we can say, root to the any node. Okay, there is only one path from root to any node. uh, if we go from root 1 to 3 is only one path. Okay, I hope you get it, because simple path means that not traversing a node twice. So only one simple path exists from root to any node. Okay, so only one simple path. Let me write in the first observation: only one simple path. Okay, now the second observation, this is not an observation. Okay, this is the solution approach I am going to take here, is that we can find the uh, initially we'll find the all the possible paths, sum of all the possible paths from a root to any node. Okay, so let's take one example. Let's say this is like this: 1 to 2, 2 to 3, 3 to 5, and let's say there is a age from 1 to 4. Okay, let's say the weights are, let's say 1, 2, 3 and 4. Okay, so initially we'll do a DFS and we will find the weights from root node to a node. Okay, so the value will be 0 here. The sum of node 1 will be 0. Now for node 2, the shortest path from 0 to 1 to 2 is 1. Okay, so this will be 1. For the node 3, this will be 1 plus 2 3. For node 5, this will be 1 plus 3 4. And for node 4 also, the path will be only 4. Okay, so this is the entire thing we have calculated. Now if we don't have the type 1 queries, that the problem becomes quite straightforward. We can do a simple DFS and pre-calculate the sum of the weights till node I, and then we can easily solve the type 2 queries. But here, let's say in one update operation, this can change to 5. Okay, so let's say if this is changing to 5, then only one value of only one node is changing. Okay, value of only one node is changing. But let's say this is changing to 5, then the value of two nodes are changing. Okay, value of this node is changing, three nodes are changing actually. 2, 3 and 5 is changing. So what we can say, that if a age is getting changed, then the subtree below this node, let's say age is between like u to v, right? Let's say age is between u to v. Okay, so let's say we say that u is the parent node and v is the subordinate node or child node. Okay, in which sense we can say that u is parent node? If one is closer to u, then you can say that u is the parent node and v is the child node. Okay, so what we can say that if we change the value for the age u to v, then all the sum values in the subtree of v is changing. In all the values in the subtree of v is changing. Okay, now this is the second observation, or you can say third observation. Okay, so if we say that u comma v and v is the child node, then all the values, some values in the subtree of v is changing. Okay, now I will discuss my solution approach. I think there might be easier solution than this, but I find my solution quite intuitive. Okay, so before discussing my solution, I will try to discuss one thing that is needed in this problem statement for me, that is Euler tool technique. Okay, I will explain this. I will attach the link of this in the description box, but let me discuss what is a Euler tool of a tree. Okay, we can flatten a tree using Euler tool. Okay, so let's draw the tree again. Let's say 1 2, we have 3 and 5, and this is 4. Okay, so we can flatten a tree using Euler tool with a simple DFS. Okay, so let's say we go from 1 to 2. Okay, so when we are at a node, we'll add that as at the start. Okay, 1, then let's say we are at 2. Okay, we are at 2. Now we'll go from 2 to 3. Okay, 2 to 3. There are no child nodes of 3, right? Or all the child nodes are visited, so we'll write 3 again. We'll write 3 again. Okay, then again we will go to 2. Now we'll go to 5. Okay, I will write 5. All the child nodes of 5 are now visited, so we'll add 5 to this, and again track back to 2. Okay, now all the child nodes of 2 are already visited, so we'll add 2 again. Okay, if initially when we are at a particular node, we'll add that in the flattened vector, and whenever all the child nodes of the particular node is visited, we'll add that again. Okay, now we'll track back to 1 after visiting 2. Now 1 has a child node, so we'll go to 1 to 4. Now 4 has all the nodes visited. Okay, oh, what happened? So 4 now, so we'll add 4 twice, and after that we'll track back to 1, and we'll add 1 to this. Okay, now you can see this is the flattened tree. Okay, now let's say we are changing the age of 1 to 2. We are changing the age of 1 to 2. So 1 is our parent and 2 is our child. Okay, so all the childs, okay, so all the childs of 2 are getting affected. Okay, child and 2, all the subtree containing 2 is getting affected. So here you can see that let's say this is the starting value of 2 and this is the ending value of 2, right? Starting value of 2 and ending value of 2. So we can add the difference. So initially let's say age weight is w, and we are changing that to w bar. So we can add w bar minus w, the change, okay, the delta, to all the nodes in the subtree. So we'll update all the values in this okay, so we'll add this value w bar minus w to all the nodes in this subtree. Okay, all the nodes in this subtree. I hope you get it. So this is the thing we have to do. So we have to find the Euler tool or Euler tool, and we will find the starting node, a starting value of a particular node and ending value of a particular node, and we'll update all the values in that subtree, by the delta. Okay, by the delta, let's call it d. We'll update all the values by d. Okay, and after that what will be our answer? Okay, so our answer for a particular node, okay, our answer for particular node, let's say sum of particular node, let's say n, sum of n, the answer will be answer of n will be sum of n, which we have already pre-calculated, and we can query for the starting value. Okay, we can query for the starting value, okay, for this node, because this will contain all the sum of all the deltas. Okay, so we can do query of the starting value of n. Okay, then this will be our desired answer. Okay, so this is the solution. Before jumping into the code, so we are doing some range updates. For range updates, we'll use lazy segmentary. You can read about lazy segmentary or lazy updation of segmentary. I will provide some link of in the description box. So lazy segmentary will use that for range updates. We'll do range updates and point query. So lazy segmentary is a possible solution for us. Okay, now let's jump into the code. So the code is divided into some parts. So first one will be the Euler tool. In the Euler tool will be a simple DFS. So we are calculating the sum of a node in the Euler tool itself, also start of a node and end of a node. Okay, this is start of a node and end of a node. Okay, so we are initializing timer by one, timer with one, and whenever we are at a node at the first time, we are initializing starting node by timer, and whenever all the nodes, all the children are visited, we'll add end of node as timer. Okay, this is the starting node and this is the ending node. Now sum of a node will be the sum of its parent plus the current edge weight from parent to this node. Okay, so sum of edge, whenever we are visiting from a node u to v, so we'll do sum of v as sum of u plus the weight w. Okay, so this part of his Euler tool is simple. You can visit it again. Now this part is for segment tree lazy updation. I am not going to explain how lazy segment tree works. I will provide a link of a YouTube video in the description box. You can check that out. This lazy segment tree update, what update does is that it will take query L and query R. So we'll change all the value from query L to query R by a specific value val. Okay, so it will add val to all the nodes from query L to query R, and get function will give us a value of a particular index. Okay, value of a particular index. So you can think that this is a black box. The black box is a lazy segment tree which gives us the operation update for a particular range and gives us the operation query for a particular index. Okay, here we are building the initializing everything. We are also initializing weights. So weights will be for a pair u comma v. This will give us the weight of the particular edge. Okay, this is a map. Okay, now this part is initialization. So we are initializing timer with one also, and we are doing a Euler tool. Okay, Euler tool you can say. So now we are visiting every query. If the query type is one, we are doing u equals to query 1 and v equals to query 2, because u will be our parent and v will be our child. Okay, u will be our parent and v will be our child. Now if starting u is greater than starting v, that means u is under v. Okay, u is under v, because let's say 1 to 2, so starting of u will be greater less than starting of v. So in case this is greater, the starting of u is greater, then that means the u is a child. So in that case we are swapping u and v. Okay, so v will always be our child. So we are updating the value starting of v and ending of v, from starting of v to ending of v by the delta. The delta will be now w bar and the previous weight w. Okay, w bar minus w, and after that we are changing the weight of the edge u to v by w bar. Okay, this part is for updation, and for querying we just doing sum of v or sum of a particular node, plus we are querying the uh, um, starting point. Okay, we are querying the st of I of the particular node. You can do for ending of node also, but that does not matter actually, because the starting of node and ending of node will have the same value. Okay, that's what we are doing. I hope you got the explanation. So what is the overall time complexity? The overall time complexity of segment tree is order of n log n. So we are doing order of n log n, and order of n log n plus for every query we are doing some log n operation, so it will be order of n log n plus q log n. Okay, this is acceptable. I hope you got the solution. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. If you find this video helpful, please like the video, subscribe to the channel, and also share among your friends. I will attach the code link in the description box, and also some links for Euler tool and segment tree lazy propagation. Thank you for watching.